On the territory of our country, thousands of square kilometers are impassable for ordinary vehicles most of the year. It is known that cars with all-drive wheels on ordinary tires do not drive well on the off-road. Siberian snow that is 1 meter long is not available even for the ZIL 157. Back in 1959, the first three-axle cars, with a new chassis scheme, were created at the Likachev automobile plant, which made it possible to use large-diameter wheels. The advantages of the new machine in comparison with the standard one on virgin snow are beyond doubt. The trail shows a sharply different nature of the interaction of the chassis of cars with snow. On this model car, it was found that the specific pressure for snow should not be lower than 0.3 kilograms per square centimeter. Unlike conventional cars, this model has a new quality: it can overcome ditches. Experiments on virgin snow have shown that a large ground clearance is a necessary condition for mobility in deep snow. For an experienced car is 700 millimeters. In terms of cross-country ability on snow, a car on such tires is close to the GAS 47 tracked snowmobile. These experiments were carried out back in 1961. However, the transition to the new scheme was associated with a revision of views on the design principles of off-road three-axle vehicles. 10 years ago, the new scheme was not adopted as the basis for a multipurpose Army vehicle. Despite this, the plant continued to search and work out schemes on prototypes of cars with a uniform arrangement of axles along the length. Model of a multipurpose three-axle Army vehicle ZIL 132. He has the same principles as in the previous car. Loading capacity of the model is 3.5 tons. Engine power is 180 horsepower. Specific ground pressure is half that of ZIL 131. The ground clearance is doubled. The middle wheels have no suspension. Front and rear wheels are steerable. The steepness of the slope is 41 degrees. The ZIL 131 car, with the usual tire size, cannot overcome such a rise. The specific pressure is high. A ditch of a normal profile. The car, made according to the usual scheme, gets stuck in it. With the current trend of sheltering manpower and equipment in deep trenches, such obstacles can be very frequent for an Army vehicle. The new scheme of 3 axes in these conditions has a clear advantage. With the new scheme, the wheels do not follow the profile of the track, but pass over the depressions, which significantly reduces the overall resistance to movement, and is the most important factor in increasing the vehicle's cross-country ability. The same quality increases the survivability of the vehicle. Soil test track. Only Caterpillar and 4-axle vehicles can walk on it. The 4-axle vehicle with electric transmission is followed by the experimental 3-axle vehicle ZIL 167, which also has a new layout. It has tires with a diameter of 1,800 millimeters, and the ground clearance is 800 millimeters. In terms of cross-country ability, among wheeled vehicles, it has no equal. The ZL-132 model moves confidently enough in these difficult conditions. The advantage of the new scheme is realized here mainly due to the increased ground clearance. Loft will drive along the side, and oversized tires. On the most difficult section of the track, ZL-132 can successfully maneuver to avoid a stuck car. Testing here of ZL-131 vehicles, active road train ZL-137, and Ural 375 vehicles made according to the usual scheme confirmed the decisive advantage of ZL-132 and ZL-167. The swamp is the most difficult obstacle for wheeled vehicles. At ZL-131 specific pressures are too high, and the chassis is completely unsuitable for such conditions. ZL-132 has a sealed casing with a smooth bottom, and a significant advantage in specific pressure. The direction of creating deep roaming wheeled vehicles, taken in the 60s, is incorrect and has now been rejected abroad. Overcoming water obstacles in this way is associated with the difficulties of reconnaissance of the bottom, and in the cold season it is unsafe for the crew. Naturally, the cargo on such a vehicle must have special packaging. A more correct direction should be considered the tradition of high cross-country vehicles of the qualities of buoyancy. Taking into account the requirements for sealing the cabin due to anti-nuclear protection on Army vehicles, as well as the desirability of protecting all units from dirt when sealing the car, you need to make it floating without betraying special amphibious forms of the hull. The ZL-132 model car has a sealed body. A water cannon is used to move on water. The speed afloat is 9 km per hour. Adequate freeboard allows the vehicle to navigate a wide variety of water boundaries. This is a very important tactical quality of a new car. Studies have shown that during a day's march of 100 kilometers, a convoy moving through the terrain can meet up to 20 water obstacles. The experience gained by the plant made it possible to create a floating air-transportable three-axle vehicle designed for special purposes. The new cross-country vehicle has a floating body, a water cannon, will drive locked along the side, oversized tires, front and rear steered wheels. This amphibious vehicle is used as a search and recovery unit. It is equipped with a complex of radio communications, navigation, and search equipment, as well as a crane installation. With a chassis carrying capacity of 5 tons, its own weight is 6.5 tons. Such high performance is achieved through the use of an aluminum frame and plastic housing. The vehicle can be transported by on 12 aircraft and Mi-6 helicopters. Experimental studies of the cross-country ability of wheeled vehicles allowed the plant to work out a new chassis scheme for a three-axle vehicle. The first car, made according to this scheme, passed state tests and was accepted for supply to special units of the Air Force. Developing the further use of the new chassis scheme, the plant is developing a number of other three-axle vehicles for the needs of the Army and the national economy. The rejection of the old principles of the design of off-road vehicles and the application of the experience gained allows us to take a new serious step in improving the tactical and operational qualities of Army vehicles.